So my name is Chris Williams. I'm currently the Informatics Fellow at the University of Michigan, at least until the end of next month, at which point you will going to show me the door and advise me to get a real job for once. And this morning I'm going to be talking about the concept of an open algorithm standard for whole-site image viewers. Typically algorithms come in two flavors, either to run offline or in real time, and this talk is focused specifically on algorithms that do real-time analysis for whole-site images. As far as disclosures go, I do have an equity stake in a company that's currently developing a whole-site image viewer. However, this is based on my experience at the University of Michigan and developing a image analysis algorithm there. So I would argue that, that although there are many, that digital pathology does solve a lot of logistics issues and has the potential to provide a lot of convenience for pathologists, the real value is actually the new possibilities that it opens up to really transform a field of pathology. And so that's why I think that this concept is potentially very powerful to facilitate incorporating new algorithms into whole-site image viewers. And so this came about from a problem that we actually had at the University of Michigan. I was working on a next generation of algorithm that's gone through several iterations in Yule's lab. We got to the point where we had an algorithm. We worked very hard to optimize it, get it to run as fast as possible, port it to the GPU. But we were still, it's targeted towards regions of interest analysis rather than a whole-site image. And we found that was really limiting the pace of discovery. And so we kind of looked around. There wasn't really an obvious way to incorporate it into an existing whole-site imager. So the option was to either develop a whole-site image viewer just for the algorithm, or to try to work it into some existing framework. And so today I'm going to cover the basics of what we did, the kind of who, what, where, when, and why, and how. We've already actually covered the why. So the what, basically what I'm advocating for here is a standard communication channel that both the whole-site image viewer as well as the algorithm can both count on for two reasons. One, to abstract away the implementation details of the algorithm from the viewer and the implementation of the viewer from the algorithm. And once you kind of sever that tie, it makes it very easy to both interface multiple algorithms to a single viewer, as well as use the same algorithm on multiple viewers. So the big question was, how do we do this? So with an algorithm that was originally designed to work on small JPEGs, it was really not entirely obvious how to move forward into getting this algorithm to now work on whole-site images. Obviously, the scale of the problem increased exponentially, and so we tried to kind of take a step back and go back to first principles and kind of imagine if we had the optimal scenario, what would be the easiest way to take this algorithm and communicate to multiple whole-site image viewers. So one key technology that really facilitated this was being able to encapsulate the algorithm using a container technology. The most popular of which is currently Docker. Until recently, that was kind of limiting in the fact that you could only use the Linux operating system with containers. But as of the beginning of this year, Microsoft has actually started supporting Docker containers with their Windows Server. So that actually opens up a lot of possibilities for people that are developing on the Windows system. So the next thing to consider was what kind of interface we would use between the algorithm and the full-site image viewer. And so we decided to try to leverage an existing interface that all image viewers actually already use, whether it be a thick client or a web-based viewer. Most are typically communicating with some type of image server using HTTP to request the actual tiles that need to be displayed on the screen. So we wanted to keep it simple, keep the development effort to a minimum. So basically, just forking this feed and reusing it for another purpose. So as the viewer is asking for tiles to display on the screen, it also sends that same information to the algorithm for processing. This also, using this topology, you also get scaling for free. Assuming that your algorithm is a containerized, you can easily spin up multiple instances and simply put those behind a load balancer. So if you're displaying 12 tiles on the screen, assuming that you have the hardware necessary, you can easily spin up 12 instances of your algorithm, put it behind a load balancer, and now the bottleneck becomes the processing time for a single tile rather than for all 12. So kind of the workflow would be when the viewer loads the algorithm, there's probably going to be some type of configuration step where the algorithm has to communicate kind of what endpoints it supports, if there's any user provided parameters, what the expected tile size is, and such. Once the configuration is complete, as the algorithm is requesting tiles, it also sends a request to the algorithm with the name of the whole site image that is currently being viewed, the location of the tile, what the user parameters are, and the algorithm now has enough information to actually process the tile and return the results. So once the processing is complete, there may be some type of quantitative value. In our case, there's actually an alpha mask that's returned to the viewer that's simply laid on top of the tile, and so the viewer can display that to the user. So my question is who cares about that? And I would propose that you do. If you're a digital pathology consumer, obviously having access to as many algorithms as possible and not being limited to the algorithms that are available when you first purchase your viewer would be valuable. If you're an algorithm developer, obviously having the widest distribution possible and connecting with as many end users as possible would be very valuable. If you're a digital pathology solution provider, maybe not. If you're vertically integrated and your algorithms are your competitive advantage in the marketplace, maybe this wouldn't be something that would be so attractive. This is more, I don't have any personal knowledge of people doing this, but so this is more of a hypothetical situation and an extrapolation of what software companies have done in the past. But I would propose that it actually could be valuable in being able to deliver the most value to your customer in the form of algorithms with a minimum development effort in terms of time and money. So when I would say sooner rather than later would be good. And as far as where, I might as well start here at API 2017. In conclusion, if you're a consumer of a whole site image viewer, I would say that that you should expect the providers to be able to incorporate new algorithms as they're coming out. As we heard yesterday at HEMA, machine learning, deep learning is a very active area, and we expect new algorithms to be around the corner. If you develop algorithms, I would just encourage you to develop them with that distribution in mind up front, rather than having it be an afterthought like it was for us. And we can't really propose a open standard by ourselves, so we would encourage people that are interested in this to contact us and And here's my personal email and also the email of the team that I collaborated with at Post Office. So with that, I'd like to thank Dr. Eva Belize and the team at Cycles that helped make this possible. And with that,